just to get you started, let's say I have 3x squared, 3x cubed plus x squared plus 2x plus 1, and I divide that by x minus 1. I'd like everybody to divide this now, please, just to get started. So give me the division here, please. X cubed plus x squared plus 2x plus 1 divided by x minus 1. X minus 1, yeah. Okay, some people finished? No. Not yet? You should get a remainder at the end. Yeah, so if you're thinking you did something wrong, you didn't. In fact, you should get a remainder of 7 at the end.
Yep.
Yeah? Okay. So we'll come back to this in a moment, but what we're trying to answer today is there a quick way to work out the remainder without the need for long division? So that is, can we find the OR quickly but without long division? And the answer is yes, and that's the remainder theorem. And I'll go through the proof now of it, okay? So can I scroll down? Yeah. Okay, thank you. Remainder 7. That's not a 7. Not even close to a 7. 7 then. Okay, so I'll come back to this in a moment. So this is the idea. We have some cubic. We'll say ax cubed plus bx squared plus cx plus d. Although it doesn't actually matter if it's a cubic, it could be quadratic or whatever, doesn't matter. And we want to divide this by, let's say, x minus k. And I would like a formula. I'd like to divide this, get the result, and the result then is a formula for finding the remainder. So the idea is, I take this, I divide it in, and then at the very end, what I'm left with is like a formula for the remainder. So for example, like just a silly example, imagine the remainder was something like a at the end. Then means I know that when I divide this, the remainder is going to be this number. Now it's not going to be as simple as that because, for example, here the 7, wasn't that number. So we'll see what we get at the end. We'll divide and we'll see what formula we get. So the proof is a little bit long. We have to watch carefully. The steps aren't difficult. It's just there's a lot to write. So it starts off okay. What's the first thing I need here? If I'm ax squared. So this will be ax cubed minus akx squared. Okay. So now we subtract. Of course they cancel. And here I'm left with b plus ak x squared plus cx plus d. Now I'll stop for a minute to let you write this much down and then we'll continue. Okay. You have that? Can I continue?
Yeah.
So what's the next term here then?
B plus A K.
Yeah. B plus A K X then. So when I multiply, I get B plus A K X squared minus BK, yeah, AK squared X when we multiply out. So subtract again, they're gone again, and now I'm left with brackets C plus BK plus AK squared X, and then I carry this down D. Okay, so there's one left. So the last one up here is all of that. C plus BK plus AK squared. And then we multiply and we get C plus BK plus AK squared X. And then I have minus, and then I multiply by CK plus BK squared, where I've lost it now, plus AK cubed, like that, and I finish, and this is my remainder. Remainder equals D plus CK plus BK squared plus AK cubed. Or, if I rewrite that a little bit, I get remainder equals AK cubed plus BK squared plus CK plus D, which looks familiar. What is this?
Bottom one.
Yeah, it's what?
Same question.
It's the original, yeah. It's the original. Here it is up here. The original cubic, except instead of X, it's K. So I get this very neat result at the end, that the remainder is the cubic, but with the value of K placed into it. And this is the Remainder Theorem. Now, I'll give you an example of how this works. If I go back just for a moment to the original, if I look at this, this is like my K. My K here is 1. So if I put 1 in here, 3 plus 1 plus 1, plus 2 plus 1 makes 7. So now we have a way to get the remainder without dividing. We'll do another example if you just want to finish writing this down. But this is the result here. Yeah. Zoom out or scroll up? So how far? Yeah, okay. So let's say I have x cubed plus x squared plus x plus 1, and I divide it by x minus 2. What's the remainder? It will be 8 plus 4 plus 2 plus 1, which is 15. So now I can get the remainder without actually dividing. So it's a very, very useful result. Very, very useful. Now I know the remainder without dividing. Some people maybe have seen this before. Yeah? You seemed familiar for you.
Yeah.
But was it presented like this or differently? No. Do we get the idea for this? So, I'll do another example. Can I scroll down a bit more? Okay, one sec then.
1x x plus something.
Yeah, but yes, we'll do something with a plus then. Can you check your notes and look for the very first long division example I did with a plus in it? What was the first example I gave you? Can I scroll down? Yeah. The very first one I did on the board. What is it? Yeah. 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 Minus. Divide.
Divided by x minus 1.
Oh, that's a minus.
There's the minus.
I wanted a plus one. Anyways, it doesn't matter. What remainder did I get here? Did I get 0 when I did this in class?
Yeah.
So let's check it. I take this, make it a 1, and put that in. So I have 56, 1 cubed, minus 25, 1 squared, minus 28, 1, minus 3, which is a 0. So the remainder here is 0. Matching what I got when I did it. Yeah. So what we just need to learn is how do we change this into the number value? Very easy. What I'm doing in my head is I'm making this equal to 0 and just getting x. So for example, x minus 1, that means I should use 1. X plus 1, I should use minus 1. And then what about something like 2x plus 1? Minus 1 over 2. Okay, so this is called the factor, and this is it's like the root, although it's not, we don't necessarily know if it's a root, but it's like the root. Yeah, let's have a look. I'll give you one to try now, just to make sure you got the idea. Can I scroll down? Yes. Bruce? Is it? Is it? I know you weren't speaking Chinese because you value your face too much. You'll be good? If he wants his face bent out of shape, he should continue speaking Chinese. If he likes how his face looks, he should only use English. You can connect the dots yourself, okay? No, don't explain it to him. Don't explain it to him. And continue. So, let me give you one to try. 9x cubed plus 29x squared minus 28x minus 3 divide x plus 4. So I want the remainder here. Yeah? Okay. Try this one, give me the remainder, and I'll check with Bruce for the answer in a minute. Okay, some people should have answers now. Bruce, what's the answer? Okay. Is Is he doing it calculator free? No pressure then. Bruce? Got an answer? Give him a hand. Jerry, have you got an answer?
I don't know if you right or not.
We'll see. What's the answer?
I got minus.
Yes? Minus what? Continue.
Yeah, it is correct.
Yeah?
But
So far so good. Minus?
3.
Bruce, what did you get?
I don't want to.
That's okay. Anybody else get an answer?
Yeah,
Minus 3 then. Yeah. Okay. Good. Okay. Let's do a harder one now. So scrolling down. Okay, let's see. The remainder of 2x cubed minus 3x squared plus 8x plus p divided by I don't know, let's just say x plus 1 is 14. Find p. So in this example, I've told you what the remainder is, and you have to use that to find the missing number in the cubic, the p that is. So we know when we divide by x plus 1 we get a remainder of 14. So we know that the remainder is 14. You agree? Good, yeah. So, what do I put in for x? Minus 1. So we have 2 minus 1 cubed minus 3 times minus 1 squared plus 8 times minus 1 plus p. That should equal 14. Minus 8, minus 3, minus 8 plus p equals 14. What's that? 7. Minus 7? No.
Minus 2.
No, the first one.
First number.
First number is minus 2, yeah.
Yes, not minus 8. Sorry, in my head that went inside by accident. Minus 2, so that's minus 15, is it?
Yeah.
I mean, just here, these three.
13.
Minus 13, take it over here.
27.
Yeah, 27 then. Okay, so that's the missing number p then. This is a common question in the exam, but the next example I'm going to do is more common than this. Okay, so this might be like a short question in section A of the exam. Now I'll do a longer question which will be like something in section B of the exam. The exam has 2 parts, short and long, so let's go down now to the B part. Can I scroll down? Yeah. Okay, so this time now. Oh, do you need to write it down? Or how I got it? Can I leave it here? Yeah? Okay. Let me give you this one to try. So, px cubed plus 51x squared minus 56x plus q divided by x minus 3. The remainder is 1020. Use your calculator, you'll be fine. And then if I divide it by x minus 2, instead the remainder will be 308. So, using these two pieces of information, we need to find P and Q. Very similar to the last example, but you have twice the job to do here. I'll let you try it before I give you the answer. So, give this a try and see if you can get it. Yeah.
Why we put -1?
In which the previous example?
Yeah.
Let me just scroll back. This one here?
Yeah.
Because what you do is you take this, can you see this here?
Yeah.
I'll just write it over here. And you say x plus 1 equals 0. So what does x equal? -1. And that's what you use back into it. Yeah. Calculator time.
Yeah.
Finished? Yeah, 2 of them, correct, yeah. Got answers? What you get for P and Q then?
27 and 0.
Sounds like it. Okay, let's have a look at this now. Right, let's have a look at this one now. So, we know that if I put in 3, so that's 125p, 510 minus 51, isn't it, for the next one? What's that? 459 is next, is it?
Yeah.
And then minus 168. I'm putting in 3 in here.
125p.
For which one?
125.
Ah. The next one's 125?
No. We're talking about the first one.
Oh! No, I understand. Ignore me. 127 is 3 cubed. I was thinking of something else.
It's just 27. It's just 27.
Cubed. 27, thank you. What number did I have here then?
459.
459. It's the small numbers that are hard for me. The big ones are much easier. Next one, minus 168. Yeah, you see, these are no problem. Plus Q equals 1020. Okay, so we can clean this up a little bit. 27p plus Q is 1020 minus 459 plus 168. 729 is it? 729 you said? Yeah. 27p plus q, 729. Now that's great, but it's not enough because we have p and q in it. So as you probably realize, you'll get another equation when you use the second point of information. So the second one now, putting this in, 8p plus 204 minus 112 plus q equals 308. So we have 8p plus q, what's that, 104, 260? 216. Okay, that's not bad actually, because these are quite straightforward to solve. What do I do to solve here? Yeah, or just minus them. The 27p minus 8p is 19p. Q's cancel. 729 minus 216, what's that? 513, is it? And then that divided by 19 is 27?
Yep.
And then I put 27 back in, say here, and I'll get Q is 0. So 27 and 0 are the answers then. Okay, it's a difficult one, but this is the type that you get for the exams. I'd say I've seen this about half the time on exams, this question. So it's common enough for the exam. Okay, one more now. One more of these. Find P and Q if (15x squared plus 13x minus 6) is a factor of px cubed plus qx squared minus 45x plus 18. Okay, again, I'll give you a couple of minutes to try it first. Much harder now, we'll have to think about this. Yeah. And just remind us, factor means what about the remainder?
0.
Yeah. Okay, we'll do this one together now because I'm not sure how many people figured it out. But what should we do as a first step? Factorize this quadratic. So what are the factors here? Did anybody get them?
1 over 3 and minus 6 over 5. Oh, I covered that.
1 over 3 and...
minus 5x plus 6.
like this?
5x.
Minus 6, 15... No, this isn't what? 18... No, this is it.
Yeah.
As equals to 1 over 3.
Yeah. Yeah, this is it. This is it. This is
Yeah.
it. Okay. What's next?
Next to
Why? Why are you allowed to do that? So this is important. If I tell you that this is a factor,
Yeah, you're not going to hear it.
how do we know that these are factors? Do we know? Are they always factors? Must they be factors? Just because this is a factor doesn't necessarily mean automatically that these are factors. Or does it? I mean, you have to think about it. You can't just jump and say, well, this is a factor, so each of these is a factor. You need to think about it. See, I can see some people thinking about it, which is what I want. So let's just go to the side and check. So if I say, I don't know, let's just say A is a factor of B. Thank you. Autocomplete. A is a factor of B. What does that mean exactly? That means I can say B is some number multiplied by A. So for example, if I said 6 is a factor of 30, then that means I can say 30 is 5 times 6. Yeah? Okay. So let's say now, if I go back to the side, we'll keep it like this. We'll say A is a factor of B. So that means B equals some number multiplied by A. What else do I say? Oh yeah, and let's say C is a factor of A, and C, oh no, different letter now, D is a factor of A as well. In other words, A equals C multiplied D. Yeah, so C is a factor of A. So I can say here A is equal to some number multiplied by C. And here I can say A is some number K multiplied by D. Yes? And then, don't rush me now, don't rush me, I'm very excited. Let's see now. If I go back up here, I could say, if I take this, put the first one in, I could say B equals NMC, or if I put the second one in, I can say B equals NKD. So I can say C is a factor of B, and I can also say D is a factor of B. So in other words, if C and D were factors of A, and A was a factor of B, it is right to say C and D are factors of B. So going back to the question, if these are factors of this, and this is a factor of this, then it is right to say that they are factors of the cubic. It is right to say that. Now, everybody had that idea, but you have to be careful because you had no way of knowing that that was right without actually thinking about it. Because it could have been wrong. It could have been that this is a factor, but we don't know that each of these are. But you don't have to worry. It is. Okay? So in other words, to keep it very simple, if A is a factor of B, and B is a factor of C, and C is a factor of D, it is fine to jump and say A is a factor of D. And if you think about it with numbers, this makes sense. 5 is a factor of 25, we'll say, and 25 is a factor of, let's say, 250. Is it right to say 5 is a factor of 250? It is, yeah. It works, but you need to think about it. Okay. So then, what do we do next now? We put this value in, and then we put this value in, and what happens? Exactly the same thing as the last example. We get two equations, P and Q, and it's just like what happened previously. Okay, I'm not going to go through it because it's exactly the same as what happened here. You make two equations with P and Q and you solve it. Now, this is an example of a very hard question. I don't even know if this is too hard for the exam, because I haven't seen it on the exam. It'd be maximum difficulty. Yeah? Yeah. So if you found that last one hard, that's okay. It is hard. It's maybe even too hard for the exam. But you must be okay with the last example, because these are very common on the exam, 50% of the time. Okay, so this is just now same as before. Right, let me give you some questions to try now. Can I scroll down? Hey, Victoria. Oh yeah, you can check in a sec. I just want to give you some questions to do, and then you can check. So, I want you to try these now, Sean. Thank you, you're distracting me. That's okay. Try these, please. 1 ABC. Yeah, you see where this is going. Now, before you freak out, question 1 and 2 are extremely short. These are so short they don't even count.
The first one is the one you gave us just now.
Question 1?
Question 6A is the one you gave us just now.
Oh, well then that means one less for you to do. Actually, you know what? That is a bit too many here. Just B will do.